The way we as a humanity, trying to combat the carbon in the atmosphere has been by many different ways. One way was to try and reduce our reliance on fossil fuel. And we've seen a lot of efforts by many of the energy companies to move away from the use of coal, for example, and start, buying offshore wind farms and solar power and whatnot. And it's a very good approach. It makes sense. That's the way to go. And it does reduce their overall carbon footprint. However, it has to be pointed out as well that even that has a carbon footprint, because to build those farms, to operate those farms, everything has a carbon footprint. And this is in a first world country. Take the rest of the world. The rest of the world is basically reliant on fossil fuel for its existence, for its development. You cannot take it away from them. They will not give it away. Okay, let's be practical here. So fossil fuel is here to stay in this form or another, and ultimately carbon footprint is out there big time. And one of the examples is you can take any of the service companies, big banks, for example. They're not responsible for directly releasing any fossil fuel-based emissions anywhere, and yet their carbon footprint is quite significant. Why? Because they have a lot of people in fancy infrastructure driving around, flying around, and all this. It builds up to a significant amount of emissions, and this is something that needs to be handled. Where humanity really stands a fighting chance, it's not on land, it's in water. For the simple reason that by design, the way the world works is the oceans and the lakes, or water in general, is where carbon goes to sleep. Water regulates carbon in the atmosphere. 83% of all carbon in the atmosphere circulates through water. And it's not through the properties of water in and of itself. It's through little creatures that are called microalgae, microscopic algae, that is so effective in capturing carbon that it is also responsible for 50% of all the oxygen we breathe on Earth, despite the fact that when you compare it to trees on Earth, it's 0.5% of all the green in the water. It's that little amount of biomass that generates all that oxygen. It's just that effective. We came from the attempt to control a water pandemia, which is based on those microalgae that overpopulates. Now, when it overpopulates, that's a problem. I equate it to a cancerous tumor. It's what is known as a nature-based carbon removal system that is actually a problem you want to get rid of. So imagine you have this cancerous tumor, which is in the form of a lot of biomass that captures fantastic amounts of carbon in the process of growing out of control. And we're able to come and trigger a biological chain of events within those toxic communities that causes them completely to collapse. You suddenly have a huge amount of biomass and carbon within that biomass that drops to the bottom and buries in the sediment. More importantly, parts of it actually undergoes mineralization, so the carbon turns into lime. The rest of it will lie on the floor of the ocean and the lake until, after a millennia, will turn into oil and natural gas. This is how oil and natural gas were made, through ancient algae and cyanobacteria dying, dropping to the bottom, and through certain chemical processes turning into those substances, oil and natural gas, which is why when we burn them, we release all that carbon. Our treatment is a very surgical approach. We take a very surgical approach, again, to trigger a biological and natural process. It's as if we're pressing a red button within the toxic communities that causes the entire toxic community to collapse. What happens immediately after is that there is no vacuum in nature. As those communities collapse with all the carbon that is accumulated in them, you will start seeing immediately a rebound in beneficial, non-toxic species such as green algae and diatoms. I don't want to get too technical, but essentially we are rehabilitating the water column. We are reintroducing biodiversity to the environment. The part where it gets tricky is how do you calculate exactly how much carbon we have removed through this process? And this is not an easy task by any stretch. We are in the process of defining a methodology to calculate how much carbon is being sequestered in the process of a harmful algal bloom remediation. It's a long process. It needs to be validated by the scientific community. It's not a simple one. We're expecting this to take between 1.5 to 2 years to be accomplished. But the important thing, and I'm putting here aside blue-green's interest, I'm saying, again, to the extent that humanity has a fighting chance against carbon in the atmosphere, it's in the water. Whether it's us through our technology, whether it's us through our methodology, the efforts and the focus needs to move to where it really counts, because right now, all the efforts, all the money is pouring to places where the impact is just negligible in absolute terms.
Got it. Okay. So water's the answer, whether it's you or somebody else finding out the technology and the ratio that works.
Correct.